So again, this is Muhammad Bakr and from Fisher team in KSA, and we are going to discuss our webinar about the secondary steel structures for MEP services. And let us head away. For people who don't know me, this is Muhammad Bakr as a field technical engineer in Fisher, almost 2.5 years experience in the technical field in designing the mechanical and chemical anchors or the installation systems, the same as we are going to discuss and talk about right now, and also giving some trainings for the anchors and fire stop and installation systems. I've been graduated from the civil engineering background with different internal and external certificates that increase my ability to enhance. And also I've got the promising technical engineer in Fisher last year in 2019. Please let me know if the screen is good and is clear for you, please. So we are going to talk about different main things in our webinar. What would be the outline for our webinar? It will be mainly about what is a secondary support system and what are the types of Fisher secondary system that we can provide and we can support you at site, and why using the Fisher secondary support system exactly and not going to different types of steel structure, and what are the main challenges and the main things that we are going to see at site, and how we solve them by the main applications and different applications that we are already utilizing our Fisher systems at the site. So jumping to what is the secondary support system in general. So a secondary support system mainly is mainly in two things: channels and accessories. What are these channels and accessories are made for? They are mainly made for supporting different types of MEP services, whether mechanical or electrical or different types of plumbing. What are these services that we need to support usually at site? It will be electrical services, for example, cable trays, ladders, trunks, electrical conduits, or even different types of panels. Or for the mechanical services, we need to support the ducting with different types like insulated, non-insulated, black steel, or GI. We have different types of pipes like firefighting pipes, chilled water pipes, or also going to the units that will be also important for the mechanical services like the FCU unit or AHU units. Let's have some pictures for some services installed already at steel structure, for example. Here on the right side or this picture, we will see a cable tray, like two cable trays supported on our Fisher support system and this Fisher support system mainly on the steel structure of this platform. On the left side, we are having riser firefighting pipes supported using our Fisher cantilever, and these cantilever are supported mainly on the main steel structure. So also, this is one of the application here, as we mentioned, like mechanical, electrical, or even the different types of units. So this is one of the main FCU units supported on one of the metro stations. As you can see it here, supported on our Fisher support system, and this Fisher support system mainly on the main steel structure of the station. So people would ask, like, where we are going to support Fisher channels, like Fisher channels, where are mainly they are supported on. And basically, there will be different types of main steel structure that we will fix our secondary steel structure on. Let us have some examples as you will see it. So this is small examples for the main steel structure. The main steel structure here can be hollow beams, hollow structural beams, or I-beams like HEB or HEI, or different types of I-beams as we can see on the left pictures. But it's mainly categorized under different main steel structures. What are those main steel structures we can fix on? It will be the main entrances, whether for metro or railway station or etc. As you can see here on the right side, this is a real and exact entrance for one of the metro stations. And you can see here our secondary support system that is mainly connected to the main steel structure under the entrance of, under the escalator, under the steel structure escalator for that station. We can see it here on a kind of drawing shape. You can see this is the main steel structure we are going to use to fix our secondary support system on these I-beams. Those beams can be hollow, or they can be I-beams. They can be different types of the conventional types of steel structure that you will be usually seeing at site. Another type, which will be the pedestrian bridge. So the pedestrian bridge here will be mainly, one second. So the pedestrian bridge here will be mainly for any kind of connection between, for example, between two types of metro stations, or between the railway stations, or maybe inside the airport, or sometimes between two high-rise buildings. You will see just such type of pedestrian bridge where people can easily having some access between those two buildings. So it is a picture for the pedestrian bridge, as we can see here, for some kind of longitudinal I-beams and for some different types of curved I-beams, that it will be giving a similar shape to a canopy or something like this. What are another types of fixed main steel structure? It will be usually the mechanical floors for different high-rise buildings. Usually you will be specifically in the high-rise buildings, you will see one dedicating floor for running some services and circulating some services there. As you can see here, in one of the high-rise buildings, in the last level of that, you will see some main steel structure, and there will be some secondary steel structure in order to support what? To support the ducting running in both directions. Cable trays, you can see here on the top of the picture, you will see those firefighting pipes running in different direction, whether longitudinal or in the perpendicular direction. You can see this picture here as more clearly. As I've told you, we have main steel structure consisted of corrugated sheets, and under that corrugated sheet we have hollow tubes running in different directions. So we need to find a solution to support those MEP systems. And MEP supports, like the duct you can see here, and we can see here also some firefighting pipes going on the perpendicular direction, and also some firefighting pipes, and also chilled water pipes here near the wall. We need to find a support for all these kind of systems in order to be supported safely and rigidly on that main steel structure. You can see here fischer channels are there in order to create a kind of grid channel in order to support. We will discuss that in more details in the upcoming slides. What are another type of steel structure? It will be the metro stations or railway platforms. It is the place where the people are going to wait for the services, whether a metro or some of the bus to come. It will be in a similar, the platform here, it will be in a similar shape like a canopy. It will be mainly constructed from longitudinal I-beams and also curved I-beams, and Fischer has the capability to fix on either type of the applications as per the running services. We can see here a running cable, a running GI duct, insulated duct, and you can see here our Fischer channels supporting on the main steel structure. So after we know about what are the different types or the main types of steel structure, main steel structure that we need to fix on, we need also to look about what are the types of secondary support system we need here to use in order to support our systems. So mainly in Fischer, we are having the Fischer semantic system or FUS channels, where we are using our normal C channels and accessories to support the different types of pipes. As we can see here on the left picture, we are having a firefighting pipe that we need to support on a type of hollow tube or hollow beam, as we can see here. We are having also the Fischer massive system, which will be mainly used for different types of services, however, for massive and higher loads. And we will see that in the upcoming slides. So we are having two types: Fischer semantic for low and medium weights. It will be mainly consisted of channels, cantilevers, saddle flange, and different accessories that we are going to discuss in the applications and or in the challenges. So firstly, we are having Fisher semantic system, as we can see here in the picture, channels, accessories in order to support our system, mainly for the low and medium weights. For the other type, which is for the heavy duty weights, we are having the massive system where, for example, we are looking for the pipes are greater than 500 mm in diameter. We are looking for the tunnel ventilation ducts. Supporting these services on steel structure will not be efficiently going. It will not be easy using the normal semantic system. However, we need to look for the massive or the girder types of fissure in order to support these services. So the question will come here, okay, why shall I go for Fisher system or different types of Fisher as we discussed? I'm not going to, for example, the angle bars or different types of conventional steel structure in order to support our MEP services as it can be seen in different sites. So one of the important answers for that, or many answers for that, I would like to tell you about that it will be easily in installation, fast, efficient. So it will be easily just cutting the channels and screw it. Moreover, no need for any kind of welding, because usually for such type of steel structure, people will go to the normal solution of welding, where sometimes welding will not be applicable at site. Sometimes welding will be prohibited at site, so we will not be able to do some weldings. So it will be very efficient using our Fisher system in time, material, or manpower saving. And one of the most important things, no need of any kind of drilling for supporting on main steel structure. It will be all bolting connections, as we are going to see in the applications or in challenges. Very easy, you just using the serrations or using the holes or the slots on our channels to just make the bolting, and you just bolt it and go. No need for any kind of drilling, no need of any kind of affecting the main steel structures by drilling. Sometimes this steel structure will be like a structural beam, where drilling that beam will be affecting the whole structure, which will be prohibitedly and not allowed at all. So it will be easy, also no drilling, but it will be also easy fixing and adjusting of different types of service. You need to adjust the allocation of the pipe horizontally or vertically. You just unbolt, adjust, and then bolt that again. Very easy, very time saving and very manpower saving. Also, and as we're going to see, a large number of accessories in order to support our systems, whether under the I-beam, in the longitudinal direction, or in the perpendicular direction, under the I-beam or over the I-beam. It will be very high flexible using these kind of channels instead of using angle bars or other types of steel structure. Also, and lastly, we are having different types of sizes, so it will be applicable for all different types, going from small diameter copper pipes or jumping to like 150 or 200 types of firefighting pipes, where we need to utilize the higher loads and higher factor of safety. So we can use then different types of channels as per the depth. It will be very material saving for us. And lastly, the Fisher channels mainly will be coming whether galvanized or hot dip galvanized or even in stainless steel. So no need of doing any kind of galvanization at site, which will be very time consuming, bringing some steel structure, doing the galvanization, and then testing that galvanization by some constructive tests. It will be very hard, very headache for people. However, it's very easy using Fisher channels. You just having the channel already galvanized or in hot dip galvanized for different types of solutions or environments, even in stainless steel to support some stainless steel pipes or copper pipes. It will be very easy for us going to having that ready instead of having some more additional work at site. So usually people will look for, okay, what are the main challenges? And as we can see here in that picture, and I would like also to hear from you, what could be the main challenges here we need to supporting these pipe on our hollow tube system? If anybody has a kind of guessing for that, what could be the main challenges here or main challenge to support such a firefighting pipe like 200 or 250 on that hollow tube? If anybody can give us an answer, I'll be very happy for that. So I'm asking, like, what could be a challenge? What could be the hard thing fixing a kind of firefighting pipe here on that? Does anybody have an idea, or can like give us some guessing for that? Waiting for anybody who would like to answer. So Mr. Rubin, he's saying overhead installation at high places. This is exactly one of the main challenges here. You need to have like a higher elevation to support that pipe. It will not be that easy to install some kind of overhead installation. One of the answers. If anybody can also give us one other answer for that. Usually, Mr. Opening is also tight space. It will, for example, it will be very hard on such tight space or very high elevation to also drill or do something. It will be much easier for us to just make some bolted connection, placing our channel in order to make it safe, structurally safe, and we can fix it and go. However, let me tell you about what could be the main challenges in fixing our MEP services on a steel structure using Fischer support system. So basically, it will be the large support spans. And as per the site condition, usually you will be having limited I-beams or limited main steel structure. We need to fix we need to run our MEP surfaces whether above it or whether below it. And then we need to find an important solution. Like, for example, if I'm having, and if you can see in that real situation, we are having I-beams are spaced in 9 meters. And at the same time, I would like to run cable trays support system between those I-beams. And as you know, for cable trays supporting as a maximum support distance, we need to support that every 1.5 or every 1.5 meter as a maximum. So what would be the solution? Fischer then will be able to give you a very efficient support system as the one you can see here in the picture between those two I-beams spaced in 9 meters. By providing a kind of support, it will be a similar or a truss look like, in order to absorb any kind of deflection or excess load on that. And if you can see here, that structure has been used and has been tested firstly in order to check the deflection by putting a lot of channels here in the middle, and you will see then what could be the deflection. Will it be exceeding the allowable one or not? So turning the main steel structure from being limited at site by providing Fischer support system where it will be able to support our system, very great advantage. What do you think of that, isn't it? So it will be very easy for us. It will be very then convenient for the people installing under secondary steel structure, instead of like finding other solution where it will not be here even. So for a large support system, Fischer will be still able to provide you with a MEP support or a secondary steel support. You can support your system very easily. And then another main challenges, where usually for the different MEP services, it will be mainly in 2 different directions. Like we will have combined services in both directions, where under the main steel structure, sometimes you will not find a place to fix. You will find a pipe running freely in the air. You will not be able to fix it that easily. You need to find some secondary steel structure has been fixed on the main steel structure in order to support your system. So this is one of the advantages, one of the challenges here. You can see here, going back to the same example, we are having one of the mechanical floors in one of the high-rise buildings. You will see different types of ducting running on the perpendicular or the longitudinal side. You will see different types of firefighting services going on also in both directions. So we need to create a kind of secondary support, a secondary grid support system, fixing this system on the tubes or in the I-beams in order to provide a channel for each and any type of MEP running in different directions. And it will allow the people also, at the case of expansion, when increasing the services, it will let them easily install the services on that secondary support system. instead of not having any option for fixing only on the limited options of the main support system. Another main challenge we can see here at site, which the picture I was asking you about, we are having a heavy loads. And as you know, as per the NFPA or the National Firefighting Protection Association, we need to multiply the load for the firefighting by 5 and plus 114 kilogram. So you can imagine how much higher load and how much are the utilization for such support we need to consider and take care here in such situation. We need to consider that huge load on those tubes and those main steel structure, on secondary steel structure, something that we need to take care, and we need to take care very carefully at the design stage. One of the other things, which will be the higher specs from the consultant, for example, when he will require some seismic support or some horizontal restraint support for the pipe. So we need also to look for the seismic design support by providing some, for example, rigid or restraining using wires or using rigid support system. So some of the high specs, it will also be one of the main challenges here under the steel structure that we need to utilize and we need to use and we need to provide to the customer in order for the system to be safe, secure, as per the specs. One of the other thing, the fire rated support, it's very important that, and as per the specs, sometimes the customer will ask or the consultant will ask that fixing the system, our secondary system, whether on steel or whether in concrete, it has to withstand, for example, 400 degrees Celsius for 2 hours, and still the system will be safe, still the system will be able to take all the loads. People, and as per the specs, usually in case of fire, usually we have to provide a secondary steel support system that it will be able to take all this kind of loads in 2 hours for 400 degree, and in order not to affect the services and also not to affect or harm the people are going and walking, for example, below these services. So the fire rated specs must be there, and it must be taken into consideration for fixing our secondary steel support on our main steel structure. One of the great things and one of the important challenges here, and if you remember, as we saw in the entrances, we are having inclined entrances where the services also need to be inclined. So in order for that, we need also to create a secondary support system where it's also inclined in order to support these different types of MEP services safely, structurally, and to be applicable under the inclined entrances. So inclined services, one of the important challenges that we will see in the upcoming slide, how we are going to solve these challenges. One of the also important things, for example, in the I-beams, you can easily clamp it. However, for the hollow tubes, sometimes we need also to fix it without any kind of drilling. As we can see here, for that kind of hollow tube, we need to run our channels. This is one of the applicable solutions. We run our channels above and below the hollow tube, and then we're using a swivel clamp, as we can see it on the right side, to adjust the inclination, because also it will be hollow tube, sometimes it will be inclined also. So we need also to adjust the inclination using the swivel clamp by providing sub-steel structure below and above the hollow tube in order to support safely different types of, for example, pipes, as you can see here, a firefighting pipe. So going from challenges to application, we will see what are the challenges here, and we will see in the upcoming slides how Fischer are able to solve these challenges through the application that we already provided and we already installed at site. So one of the main challenges or one of the main applications here, it will be the mechanical floors on the high-rise building, as we can see. So what are the challenges we already talked about? Like we have services in both sides. How we solve these challenges? By providing steel structure in both directions, fix it on the hollow tube inclined beams very easily and very convenient. What are the main other challenge? It will be the connection. Here, for example, it will not be a normal or single I-beam where we can easily fix or clamp. However, for such type, we need to provide a kind of special connection as we saw in the last picture, and I will show it again. And also one of the great challenges and important thing that we will be having heavy loads running in both directions. We are having firefighting, and as we mentioned, that it will be having high specs, and we're having different chilled water pipes running in different directions. We are having GI ducts, we are having copper pipes, we are having some units also we need to fix. So all these things has to be considered and has to be taken care in the design stage. So the challenges we were discussing, we are having the connection. So how is this connection is done in the real field? You can see here that hollow tube inclined. We are putting channeling above, channeling below, tightening that and making a torque very effectively and very rigidly. And also we need to reflect and change the inclination of the threaded rod to be vertically. How we are going to do this? Using our UHRS connection in order, as you can see here, fix it below and fix it on the below channel. And in order to adjust the inclination, we need to use this connection very easily, very rigidly at side in order to create our systems to be straight and at level. So one of the other application here, it will be the inclined MEP services for inclined entrances. So we have an entrance, and we have an inclined entrance where we are having also inclined duct. We are having inclined different types of pipes. We need to keep these services inclined, because it will not be applicable having these services going in a straight line. What are the challenges? We have inclined service, so we need to take care of that. How we are solving the inclined services by fixing on the I-beams, the main I-beams under the entrances, providing main fischer channels, and these fischer channels will be mainly used to fix the different types of MEP services. What are another challenge here? It will be the connection. How to solve the connection, we will see right now by different and main types of connection. And also we are having different types of heavy loads like ducting, cable trays, and even firefighting pipes, as we can see on the left side of the picture. So let's have an example. We are having an inclined service going that way under a main steel structure. Firstly, we are going to provide fischer channel, fixing on the main steel structure. We need then to fix it, and we need to make some inclination using the swivel clamp. You can see this picture. The swivel clamp will help us to adjust the allocation in order to make a straight threaded rod. Then we're going with a straight threaded rod, and then again we are fixing a swivel clamp or UHRS, as you can see it on the right side of the picture. So this swivel clamp or this UHRS accessory, it will help to make some inclination to the surface or make some inclination to the channel in order to make the surface to be running in inclined line. So what we need to do, clamping first on the I-beam, then having swivel clamp to adjust the threaded rod from inclined to straight, and then we having another swivel clamp to adjust the channel to be an inclined surface. Another main important application, fixing on a curved beam entrances. So fixing on the curved beam entrances here, it will be different challenges we need to look for: a curved steel structure, a connection of that steel structure, and also heavy loads we need to consider. So let us see that example. We are having a curved I-beam. So for that curved I-beam, we need to fix, and at the same time, we need to make the surface to be straight under the pedestrian bridge, for example. So what we need to look for, we will using a clamp hanger in order to fix on the flange of the I-beam. Right away and right under that clamp hanger, we need to using the swivel clamp, our joker here, for any kind of inclination in order to adjust the inclination of threaded rod from inclined to be straight and vertically. And then we can easily run our service easily in a straight line under the curved I-beam for the entrances. And then going to the last application here, it will be for the tunnel ventilation ducts. And for the people who don't know what are the tunnel ventilation ducts, it's a kind of services. Usually it will be in the underground stations. It's mainly used for circulating the air and take out the air from the underground stations, and you can take it out from that platform using some ventilation shafts. You can see here at the right picture how huge is that tunnel ventilation duct. It will be usually span in like 1.2, 1.5 meter wide and more. It will be also having a weight that it will be going from, for example, 300, 400 kilogram per linear meter. You can imagine how huge is that weight, where we cannot then utilize our normal semantic system. We need then to look for the higher system, which is the massive system. So what are the challenges? Huge loads, higher spans, and also the specs for such type of the duct. We need to have a support that it will withstand 400 degree for 2 hours. You can imagine how huge are these temperatures and how huge are these loads. So in order to fix such huge system under the track, how we are going to fix it, you can see here we are having main steel structure. And this main steel structure will be spanned every 2 meters, for example. And in order to support these ducts under the track, we need to have some rigid connection also between the steel structure and between the surface. What are these connections? You can see it at the picture. We are having the clamp, we having the hanger clamp to the fixed to the bracket itself, and this bracket itself will be having the connection by maintaining the vertical horizontal member. So we are having a huge load. This huge load need to be fixed above the track. We need to maintain a very important and a very rigid types of connection in order to support such kind of tunnel ventilation duct. By this, I'm ending my main application for different types of steel structural fixing our secondary steel support on. I'm very happy to reach with you to that stage. I'll be more than happy to have any kind of question from your side. I'll be very happy if you have any kind of question. And before having the questions, if you allow me, I'm going to the poll tab and answer the different types of questions that will help us and help you in developing the webinars. I'm ending the presentation to that. I'm very thanking you all for attending and reaching to that time. And I'll be very happy to answer your question. And also, I'll be waiting for you like 2 to 3 minutes for answering the polls. And while you answer the polls, I will answer some of the questions. So Mr. Kabir, he is asking about, do Fischer have a connecting elements where the distance between the main truss member is about 6 or 8 meters? And how about how much load can your heaviest cold form steel member can take in such cases? So in such higher span main steel structure, we are going to look for two main things. And if you allow me, I will go back again to that picture. Let me just have this. So as we saw here, we are having two main solutions, whether creating a kind of truss support system in order to take all the loads, or we can do some bracing to the main steel structure. It will be mainly depending on the site condition. So yes, Fischer will be able to provide you using our C channels between the main steel structure by providing a kind of truss support in order to take the deflection between those main things. And what could be the heaviest load we can take? It will be mainly related to the span, and it will be mainly related to the allocation of the load. But it will be taking loads varying, for example, from 400 to 700 kilogram. It's just a roughly estimation, but it be mainly according to the type of support, what are the type of loads and what are the type of the span. And then I'll be answering you also more specifically to your answer, and they'll send you through the email. Let me go to the again. Okay. So Mr. Khawi is asking, like, is an inclined support system seismic applicable? Yes, it will be seismic applicable. But what will be affecting whether it will be seismic or not, it's not being inclined or straight, but it will be what are the type of seismic support you are providing. And usually for the inclined systems, we are preferring to have this kind of wiring support. So this wire, it will help us to restrain any kind of horizontal force that is resulted from the earthquake. If you allow me also, I will just go back again and I will let you see that picture we saw at the beginning. So if you can see that picture, let me 1 second. Okay. 1 second. So if you can see here in this picture, if you can see here on the right side, you can see we are fixing our cable tray on the inclined surface. You can see the surface is coming inclined. The main steel structure is inclined by itself. How we are solving this? We are solving this by providing our fischer main support on the secondary steel and providing some clamps. And then in order to be a seismic restraint, we will providing some inclined, it's not showing that much on the picture, inclined wiring to be fixing on that inclined system. So this inclined wire, it will take all the horizontal supports. It will be taking all the horizontal support resulting from the earthquake. It's seismic and seismic approved one. There is no issue in having any inclined and seismic support at the same time. So yeah. So Mr. Rubin is asking if the channels are cut at site, how to make the ends rust proof. So basically, for those cutting points only, we will provide you with a zinc spray elements to just use it for those cutting elements and for those cutting areas only, in order to be a rust proof and order also to be corrosion, like minorly corrosion proof. Mainly, it will be depending on also the application itself. For example, if you're having some excessive, for example, salty areas, corrosion areas, then we need to look for the hot dip galvanized channels and stainless steel. But what I need to ensure and insist on that we are providing our channels to be already galvanized or already hot dip galvanized. So no need to create or recreate any kind of hot dip galvanizing for the channel. However, for the areas you need to cut, we will also provide you with a Fischer approved zinc spray elements or zinc spray item that it can also help you to eliminate any kind of rust. So Mr. Soroba, he's asking about the certificate. And then I will be contacting the the marketing team. Yeah, there'll be some certificate for that. And I think by this I'm ending already the question there. I'll be very happy if you any other type of question. I hope that all you answered the polls there. And by this, I am ending my webinar today about the MEP supporting on the steel structure. I'm happy that you reached with me to that stage. I'm very I'll be very willing that very hoping that you already have got good knowledge for that, and if for any just questions or more any technical or any another technical or questions or any technical inquiries, please let me know and contact me. I'll be giving you my contact details on the chat box at the end. So I'm thanking you so much. Thank you for attend and have a good day.